Okay, good morning, guys. So we're going to go over aerobic respiration real quick. So remember, when we're talking about aerobic respiration, we're talking about something that is happening with oxygen present. So we start off with our 6-carbon compound, glucose, here, and we have 6 carbons. We are going to break that 6-carbon compound into 2 3-carbon compounds called pyruvate. 1, 2, 3, 1, 2, 3. In order to do that, in order to get it started, we have to give a little investment of ATP. So we're going to give 2 ATP to start with. That ATP is going to be used, so it's going to turn into 2 ADP. In the process of breaking this 6-carbon compound up here, in the process of breaking it, we are going to release electrons, and we have an electron carrier that is going to pick them up. So our electron carrier is NAD, and remember that's our vitamin B3, so you should eat well. And it's going to pick them up in the form of hydrogens, and it's going to carry those hydrogens, those happy hydrogens, in other words, they're charged with electrons, it's going to carry them directly to our electron transport chain. I'm just going to abbreviate electron transport chain as ETC, okay? Now, when this glucose breaks, when this glucose compound up here breaks, and we have our electrons being accepted by our NAD, we produce ATP. So our output is 4 ATP. Remember, in order to make our ATP, we have to have our ADP there so that we can add that phosphate to it. This, if I look at glycolysis, 2 things. One, I can say that all of this is happening where in the cell? In the cytoplasm. I can also say that I took 2 ATP to start this reaction, but my final yield of ATP, my output of this reaction, or what did I gross from this, was my 4 ATP. But how much was my net? How much profit of ATP did I get? I got a total of 2 ATP gain. So I gained 2 ATP in glycolysis. So now let's look at this pyruvate. What happens to these 2 3-carbon compounds? Well, if oxygen is there, they will be taken into the mitochondria, into the matrix of the mitochondria. So let me label that for you guys. So they're taken into the mitochondrial matrix. It's here that these 2 compounds, these 2 pyruvate, are going to undergo some grooming. And remember, I told you acetyl-CoA does that. And remember, acetyl-CoA is a pantothenic acid or a vitamin B12 that you get from eating healthily. So in the process of grooming, I'm going to release, let me put a color on here, blue, okay. I'm going to release 2 NADH. And remember, that's going to go directly to my electron transport chain as it's made. I'm also going to release as a byproduct carbon dioxide that you will exhale out. Now that my 2 pyruvate have been groomed, they will enter into the Krebs cycle. In the Krebs cycle, we know that I am going to produce from there 6 NADH that is going to go directly to the electron transport chain, and I'm also going to produce 2 FADH2 that goes directly to the electron transport chain. Additionally, from the Krebs cycle, I'm going to produce 2 ATP and 2 CO2 molecules, carbon dioxide. So I can see that all of my carbon dioxide is coming from my mitochondrial matrix. So when I exhale out, I'm exhaling carbon dioxide that's coming from the matrix of my mitochondria. So now let's look at this electron transport chain. And remember, the electron transport chain is the cristae, or the inner membrane folds in the mitochondria. So it's the cristae, I think, or the inner membrane folds of the mitochondria. And remember, we have hundreds of thousands of these electron transport chains all over the cristae, because these electron transport chains are just 4 proteins basically put together, right? They're clumped together and they travel together, they move, because remember, a membrane is fluid, it's moving all the time. So you're having all of these electron transport chains happening all the time. You're also having Krebs cycles occur all the time. You got tons of Krebs cycles going on. It's not just one. Okay, so we have our 6 NADH from the Krebs cycle, and we have our 2 NADH from our grooming. And we have our 2 NADH from glycolysis. So that gives us a total of 10 NADH per glucose molecule. If we look at our FADH, we only have 2, and it's coming from the Krebs cycle. So let's quickly do the math on this. If you recall, I told you that for every, I'm going to do it in a different color so you can follow it. I'll do it in blue here. For every 1 NADH, you get 3 ATP. And since we have 10 NADH, that's going to give us a yield of 30 ATP. For every 1 FADH2, you get 2 ATP, and that's going to give us a yield of 4 ATP. If I look at other ATP produced by glucose, I find in this cycle, I have 2 ATP being produced from the Krebs cycle, and I also have 2 ATP, sorry, that's not what I want. That's wrong, over here. I have 2 ATP produced from glycolysis. So I can add those 2 from Krebs cycle, or the citric acid cycle, and 2 from glycolysis. That gives me a total of 38 ATP. Okay, one more thing that I wanted to talk about briefly is we know that we have the outer membrane. We know we have the inner membrane, and we know we have this matrixy bit in the middle. Well, oxygen has to come in as the final electron acceptor. So oxygen is going to come in, and it's going to come into the electron transport chain. because it is used in the electron transport chain as the final electron acceptor, and it produces water. So oxygen is the final electron acceptor in the electron transport chain, So it's the final electron acceptor in this electron transport chain, so it is, when it accepts the electrons, it produces water as a byproduct. So what do we have? We have carbon dioxide, I'm going to write this in blue over here. So we have CO2 being produced in the matrix of the mitochondria. And we have oxygen, we do have oxygen, but that's not what's being produced. We have water vapor, or water, produced in the cristae inner membrane of the mitochondria. So when you exhale, you are exhaling both the product of your mitochondrial matrix and the product of your mitochondrial inner membrane. So when you exhale, all of that carbon dioxide and all of that water vapor are coming from your mitochondria, and they are all coming as a byproduct of cellular respiration, aerobic cellular respiration. Okay, I hope that that was helpful.